Hi there, it's me again, Mr. Brash, and this over here is Mr. Squirrel, and if you've been watching my videos recently, you'd recognize him, recognize my voice, and sort of recognize this setup. And today, that's what we're going to be doing with our math, is recognizing things. We're going to try and recognize patterns with the factored form of a quadratic. Highly recommend you watch some of my previous videos on quadratics, or perhaps Khan Academy, or get yourself used to factoring and this idea of what is a quadratic and a parabola before you watch this lesson. So we're going to graph a quadratic from this form that actually goes by a couple different names depending on what country you're in or sort of who you talk to. I call it factored form, and a lot of my colleagues call it that because it comes from factoring a standard form equation. Some other people call it zero form, pretty much for obvious reasons, but you get the zeros straight out of this equation the way that it's set up. And some other call it root form for about the same reason. You get the roots directly from it. Roots and zeros are very closely related. This is the blanket form of it over here with just the letters, where R1 and R2, those are roots, okay? So this would be the first root, and that would over there would be the second root. And the word root really needs to be synonymous for a bunch of things. It's the x-intercepts if the y value is 0, and that's why we call them the zeros. And the negativity in this bracket is pretty important. It changes the way that we sort of think of things as it comes out of the equation. The a value in the front, I always call that my amplitude. I've heard different words for it, but that's what I call it. That tells us the concavity. It's positive for concave up, negative for concave down. And then the rest are just x's and y's that we would use in any sort of equation, right? Our inputs and our outputs. And we're going to practice that over here. We're going to take a look at what information does this equation give us. So I need to scroll Mr. Squirrel off the screen here, but we're going to ask, what information can I get from this equation right here? Immediately I can get, just from the a value, just from in front here, that this is concave up. This parabola opens upward because that is a positive a value, and that means that it is concave or opens up. Great. I can also get the roots. I can get the zeros. Depends on what you want to call them. If my y value was 0, then my equation would have something in these brackets that would cause 0. The 2 is just the 2. We're going to ignore the a value for now. But if x minus 1 was nothing, then this would multiply to 0. And so we would solve for that. And if you're pretty used to this now, you'd know that you can just say x is 1. Or x plus 7 may have caused that. And if you're used to that, you can say, okay, well, it's just 7. I can just say it's negative 7 rather, not positive 7. There we go. And those are my two zeros. So I've got my zeros here, 1 and negative 7. And if we're going to graph these, we'd be able to plot those directly on our Cartesian plane. So if I had, let me just do like a Cartesian plane here. Quick sketch, but I'd have a 0 at a positive 1, and I'd have another 0 at negative 7. Let's just pretend like this is my scale. We know that it's concave up. We know that we're going to have an axis of symmetry, and that's the next thing I want to talk about is where does that axis of symmetry occur for this particular parabola? Happens in the middle for all parabolas, and that's what we can really get from all of this. We can get the x value of our vertex. So we can take a look at our two different zeros here, and the x value of the vertex happens between them. And how do you get a value that is between two numbers? You add and divide by 2. And in this case, that would be negative 6 over 2, which is negative 3, which means my vertex is going to happen at about a negative 3. And so we'd have our axis of symmetry right down here at an x of negative 3. That is the x value of the vertex. How do I get the y value of that vertex? As with all videos that you're watching online, it is very much encouraged that you pause and sort of try to answer that question for yourself. Skip ahead, skip back, speed it up, slow it down, do what you need to do. But I'm going to ask you again, how do I get the y value of that vertex? Well, I take this x value of my vertex and I plug it in. And I used to sing this song. There's this old Glade plugins commercial, and their jingle was plug it in, plug it in. And so I tend to sing that in class. So we're actually going to do that. I'll do that over here on the left. So I'll say my y is equal to 2 times negative 3 minus 1 and negative 3 plus 7. And we do the algebra on that. So 2, negative 4, positive 4, oops, And so 2 times negative 16 is negative 32. So quite a very low vertex down here way down there at negative 3, negative 32. There we go. And my parabola is concave up. So it opens upward. I can pass through those x-intercepts. And there's one last point that I can get if I want to, or if I've been asked. This is a horrible sketch, but you kind of get the gist of it. There's more information here that I can get from my equation, and that's the y-intercept right here. So where does the y-intercept occur? It occurs when x is 0. So if we were just to scroll this up a little bit more, give myself some more room here. So if I'm looking for my y-intercept, I'll set x to 0, and so that's 0 minus 1 and 0 plus 7. That gives me 2 times negative 1 times 7, and so that's negative 14, and so my y-intercept down here is at negative 14. And of course I could label my zeros 1 and negative 7. And so we have enough information here to really do some damage on the graph, to really get it almost precise, even though it's a sketch. And if any of you know me from class, you'll know just how wonderful my sketching and drawing abilities are. So factored form is pretty important. We get our zeros, we can get our vertex, or at least the x value of the vertex, which we then plug in, that's my purple here, to get the y value of the vertex. And we can also get the y-intercept. We can get whether it's concave up, concave down. We can get whether it's a stretch or compression. That's one thing I didn't talk about. This one here is a stretch. It is 2 times taller. The dilation on this is that it's 2 times taller and therefore thinner than your normal parent function of y equals x squared. We get so much information from factored form. It's really quite crucial. So let's take a look at another example. I'll just go through one more and we'll get all of this information and we'll graph it. So we've been asked to determine the y-intercept, determine the roots, otherwise known as the zeros, the vertex and the concavity of the following quadratic, and then sketch that parabola as well. Now it's already in factored form, and I really should have talked about whether it's in factored form or not. What do you do? So let's just go off to the side here. If we had an equation like this, and I said, I want you to give me all of the same information from this equation. Well, this isn't in factored form. So what we would need to do is we would need to factor it first by figuring out the two values that multiply to make the last value, the 12, and add to make the middle value. Now, in this particular example, they would be 4 and 3, but you might not necessarily know that right away, and there's all sorts of different ways to factor, and so this would give us the factored form. So just backing that truck up, let's just pretend it's already, well, we don't have to pretend it is already factored. So we've got our factored form here. Let's do it in the order that they asked us to do it here for us. Y-intercept happens when x is 0. So go ahead, you figure out what the y-intercept is for me when x is 0 of this parabola. You can pause this video, get all of these answers yourself, and then compare them to mine. So this is going to be negative 32, and half of 32 is 16. So my y-intercept is positive 16. And we're going to hold on to that information for us. We're going to just kind of hold on to that and use it later when we sketch this thing or graph this thing. So what are the roots? Okay, let's get the roots over here. I'll get my roots right over here, and my roots are 8 and negative 4, and I got that really quickly, didn't I? 8 and negative 4. You might be wondering, how did he get that so quickly? Well, there's no coefficient on these x values, so it's really easy to just say that x minus 8 would have equaled 0, which means x is 8, and x plus 4 equals 0, which means that x is negative 4. Negative 4, there we go. And, it just becomes so second nature to just go right ahead and switch the signs on them and get those. So I've got my roots, I've got my y-intercept. What is the concavity? I've skipped vertex here for a second, but what is the concavity? I've got my a value is negative 0.5. So this is a concave down parabola, concave down. And now let's get our vertex. So I'll do vertex in purple again. So the x value of the vertex, let's get that. How do we get the x value of the vertex again? Well, I've got my roots, and directly between those roots, because it's a symmetrical function, I know that directly between 8 and negative 4, So 8 plus negative 4, I could have just subtracted, but that's okay. Divide by 2, that's where my x value of the vertex is going to occur. So 4 divided by 2 is 2, and so that's the x value of the vertex. And the y value of the vertex is found by plugging it in. We're going to plug it in, plug it in. I don't know why I still sing that song. That Glade plug-in commercial must be a decade old or so, maybe even more, but I still sing it. Hopefully they're not going to nail me for copyright infringement or something, but I am mentioning their product. Okay, so this is a negative 0.5. We've got negative 6 here. We've got a 6 here. And so we're half of 36 is 18. Negative times negative is positive, and so my y value of my vertex is 18. And so now I know that my full vertex is at 2, 18. I know my y-intercept is 16. I know it opens down. I've got my zeros. I am ready to graph this sucker, or at least it says to sketch. And when you see sketch versus graph, sketch just means it doesn't have to be as exact. So I'm going to hold on to all this information sort of in my memory and move on to the next page. Hopefully you have it written down on a piece of paper or something like that. And we're going to graph this. So here's my Cartesian plane. And let's just say our x scale is going by ones. So we'll just sort of label our x scale 2, 4, 6, 8. Who do we appreciate? And same thing in the negative direction. I don't know that I'll go too far here. Let's make the y scale go by 2s because I know that I'm actually going to have quite a tall parabola because of where the vertex ended up at that 18, 14, 16, 18, 20. There we go. And we know that, it'll be the same thing going downwards. All right. So my zeros were at 8. So right here at 8 and at negative 4. So over here at negative 4. So there's my zeros, 8 and negative 4. I had a y-intercept of 16, right there. And I had a vertex at 2, 18. So here's my vertex right there, 2, 18. I also know that this is a symmetrical function. So that means that 2 squares over, I'm going to be at 16 as well. So that helps me with the graphing. And, shaky hands, and this tablet kind of shakes as I go. But, oh, hey, that's not bad. Not bad, Brash. Pretty good. All right, let's get this one going down as well. And it is a curve. It's not a straight line. And it will go downward more and more as you go. But there you go. There's my parabola. That's the parabola from the previous page. Y equals negative 0.5, x minus 8, and x plus 4. There we go. And that's my sketch or graph of that parabola. I got everything I needed from the factored form. It's a really great tool to use for sketching and graphing and just getting information. If this was a scenario, let me give a word problem sort of goes along with this. If we were on the top of some platform and we were throwing a rock or a ball or something like that, hopefully you would throw it up into the air first and then we'd let gravity take it down to the ground. I could ask all sorts of things like how tall is the platform that I'm standing on? So my x-axis here might be time, and the y-axis might be height. There we go. And so we'd say, well, the platform is 16 meters or whatever the unit is because time would be 0 when you throw the ball. And then the ball would reach some sort of maximum height, in this case 18, after, let's just pretend, 2 seconds. And then gravity would take the ball and it would land. The ball would hit the ground at 8 seconds. Now, clearly it wouldn't go through the ground unless you were, some sort of superhero movie or something like that. And then if we were to sort of extrapolate or think back in time, how far would it have to go behind us to hit the ground over here as well? And there's other real life scenarios. I like to use Super Mario jumping onto a platform and stuff like that as my examples. And that's it in a nutshell. That's graphing from factored form. So I hope that you got everything out of that you needed. If you have comments, you can leave them in the comments down below. Like the video if you liked it. If you didn't like the video, pause yourself from clicking the down thumb and leave a comment or contact me and let me know why the video could use some improvements, and I'd be happy to add some addendums. Take a look at the description for links. My name is Mr. Brash. This cute guy over here is Mr. Squirrel, and he approves this video, and I'll see you later. Keep practicing math.